Hope everyone's doing well. So this is our last week of content, okay? And it's fairly light stuff, lighter stuff. So I'm going to cover the content, and then I'm going to actually begin some review this week, okay? And then next week will be entirely review. So
we have a quiz next week as
you
well.
do have a quiz covering the stuff I covered today. And then, so you will have a quiz next week, but next week will be entirely review after the quiz. And then the week after that will be the final exam, okay? So I'm just going to write down the stuff I'm going to cover this week. So this week I'm going to cover what's known as Type 1 and Type 2 errors. We're also going to cover sampling methods, okay? There's a few, I've assigned a few problems from the book that cover sampling methods, but study your notes for Type 1 and Type 2 error. I think as you guys study the practice quiz, you'll see that you need to know your Type 1 to Type 2 error stuff that I covered today, okay? And then I'm also going to just begin review, okay? So your homework for this week, okay? Okay, there's just a few problems from the book, not a big deal, okay? But the important part of your homework is to work through the practice final exam. Okay, and this is available on the web page. Okay, so your goal here is to work through the practice final this week, and next week we will spend going over everything on the practice final and any questions or issues that have come up. Okay, and in my opinion, the practice final is a pretty good representation of the final exam, and so do that. Okay. Are there any questions? Okay, so yeah, I'll just very quickly. Yes.
How many questions will the final have?
About 50, more plus or minus a couple, but around 50. Okay.
Do we get any of those like extra questions or no?
There's like some bonus built in, so if you get them all correct, you'll get over 100%. Yes. Yeah.
So there won't be anything new on the final, right? Like it wasn't a midterm, we had to study for one more chapter.
Correct. Correct. There won't be anything like that. Okay, so next week will be review of practice final. Okay, and then the week after will be final exam. And that's it. Our class is over. And so I hope you've enjoyed the class. At least it has lived up to your expectations for learning statistics. Next week will be class evaluations, so it'll be your opportunity to give me a grade. I hope I will do well, and if you like the class, you can also leave me a review at Rate My Professors. I appreciate that.
Is there like a number that we have to put in there? Is there like a class number
For
Rate My Professor?
No, for Rate My Professor, you're just going to go to the website. You're going to search for Miles Chen, and And I'll show up in two places. One is UCLA extension and one is UCLA. So it would make sense for you to leave it at UCLA extension, okay? But if you want to leave it at UCLA, that's fine too. I mean, they don't really check, but you're just going to search for my name. So, okay. So with that, let's get into covering this topic of Type 1 and Type 2 errors. Okay. These are errors inherent in any decision-making process, really, okay? Okay, so remember, I'm kind of going off the premise that statistics is about being able to make decisions based on limited data, right? Okay, and because we have limited data, there's the possibility that the data we have is not actually representative of the population, okay? We hope that's not the case, and random sampling is supposed to give us data that's representative of the population, but that's not always the case, okay? So, should give us a sample of data. Okay. But because it is random, we may end up with a sample that is not representative. Okay. And if you think about it, anytime you make a decision in life, that decision may or may not turn out the way you expect. Okay? We're hoping that when we make a decision, what we expect, like, usually we make a decision in the hope that this is a good decision or something, and ideally things go the way we want them to go, okay? But not always, right? So, and in life, there's two possibilities. If you choose to do something or choose not to do something, there's a few things can happen. If you choose to do something, that choice, the action that you do may have negative consequences on your life, okay? And so that would be a bad thing, okay? Or you can also make a decision by choosing not to participate in something, okay? And that decision may also have negative consequences that you didn't want, okay? And these are similar to what happens when we're talking about statistical mistakes, type 1 and type 2 errors, okay? So, for example, Okay, here's just a silly example, right? Okay, you're in a parking lot and you're looking for a parking spot, okay? So in a crowded parking lot. Okay, and you want a spot that is that will get you have the smallest amount of walking distance to the door, right? You want the best spot. Okay. Okay. Meaning the least walking distance. Okay, so you come across a spot. You come across an open spot. Okay, so you have two choices. Okay, you have a choice. You can park in that spot, or you can choose not to park in that spot, right? Okay, so I left a little space because I'm going to write stuff. So you can park in the spot, or you can choose not to park there. All right, and so let's say that, this is not a big deal, right? This is parking, okay? But when you choose to park in a spot, essentially, you are hoping this is the best spot. You're hoping that you're not going to find a better spot as you're walking towards the store, okay? And if you do see a spot that was better, there's just you feel a tiny bit of disappointment that says, oh, I could have parked there, right? Nobody goes home crying if this happens, but you're just like, oh man, I could have saved myself some walking distance because I'm lazy, and I could have, parked here, and this would have, saved me 20 feet of walking or whatever, right? Am I the only one who thinks this? No, right? So, okay, so that's what you're hoping for, right? You can park in the spot, so the hope is this is the best spot. Okay, and the quote, it would be a quote mistake, or there's disappointment if we come across another spot. We come across a better spot. Okay. All right. If you choose not to park in a spot, essentially you are hoping that a better spot will emerge, right? As you're going down whatever the parking lane, you're hoping that there's going to be a better spot. Every time you skip all of the open spots at the back of the lane or back of the aisle, you're hoping there's a better spot, okay? Okay, and disappointment if it turns out the spot you skipped was the best spot available, right? Okay, so essentially, in hypothesis testing, in statistics, we also make decisions based on data, okay, or based on what we think. And we can either choose to reject the null hypothesis, or we can choose not to reject the null hypothesis. And when we choose to reject the null hypothesis, we're hoping one thing and we'd be disappointed, or it would be considered an error if something else is the case. Or when we choose not to reject the null hypothesis, we're hoping for one thing, or it would be an error in the other case. Okay, does that kind of make sense? All right. So, well, anyway, so this parking thing, this is a silly thing, but essentially this this can be expanded and applied to all sorts of things, even to like picking a professor or picking a life partner, right? You're hoping that if you choose to stay with someone, you're hoping that is the best person to stay with. Maybe you're disappointed if it turns out that there's someone better. Or, if you, for whatever reason, you chose to leave a relationship, you're essentially hoping that there may be someone, whatever. Okay, so throughout life, you're going to be faced with these types of things. And, you're going to make mistakes along the way. Nobody's going to have 100% track record here, okay? But anyway, so with statistics, at the end of a hypothesis test, okay, we make a decision. Okay, we choose either to reject the null hypothesis or not to reject the null hypothesis. Okay. If we choose to reject the null hypothesis, this is the correct decision if in reality the null hypothesis is false. Okay. This is the wrong decision if in reality is true. Okay. Just want to make sure that this makes sense to everybody, right? When at the end of our hypothesis test, because we're making a conclusion based on limited data, okay? Just like you're in the parking lot, you are making a decision based on limited data. You don't know if there's any open spots, and you're just kind of saying, well, based on what I've seen, I think this is the best available spot, or there might be a better available spot based on my life experience. Okay? With a hypothesis test, based on the data we've seen, we're saying I'm going to reject the null hypothesis, or I'm not going to reject the null hypothesis. If we reject the null hypothesis, that's the correct decision if the null hypothesis is actually false. Okay? However, it's the wrong decision if in reality the null hypothesis is true. Okay? So this wrong decision, the idea of rejecting the null, but it turns out that the null hypothesis is true, this is known as a type 1 error. Okay? So I'm going to put this in red. Okay? Type 1 error is reject the null. Okay? Yeah. When the null is actually true. Okay, so this is, you know, this is an error, this is a bad thing, okay? We don't want type 1 error. Okay. If we choose not to reject the null, everything is just kind of flipped around, okay? Correct decision if in reality the null hypothesis is true. Right? If the null hypothesis is true in reality, our decision should be not to reject the null. We should say, okay, well, we're not going to reject it. And this is the wrong decision if in reality the null hypothesis is false. Okay? Because if the null hypothesis is false, we should be rejecting the null hypothesis. Okay? And so this mistake, this is known as a type 2 error. Okay? It's also an error. Okay, so these are the two types of errors. Okay, and we don't want to make either of them, but it's unavoidable. Okay. At some point. Most of the time, well, according to statistics, we should be making the correct decision most of the time. But because of the nature of random data, sometimes our data causes us to make the wrong conclusion. Okay, and so so these are the two types of errors that we can make. Okay. All right, is this okay? Okay, and so we have we actually there are two types of mistakes, and we actually have some control over which error we would prefer to make per se. Okay, so our choice of alpha. Okay, alpha is our significance level. Is directly tied to the probability of making a type 1 error. Okay, so in fact we write that alpha is equal to the probability of a type 1 error. Again, what was the type 1 error? Rejecting the null when the null hypothesis is actually true. Okay, so type 1 error is rejecting the null if the null hypothesis is true. Okay, so alpha is the probability of a type 1 error. And we actually, as researchers, we actually get to choose our alpha. Okay, the kind of the default level of alpha is 0.05, but we actually have a choice, okay? Okay, and so if we want to avoid type 1 error, okay, if we really want to avoid type 1 error, we can choose to use a smaller alpha. Okay, and if we do not mind type 1 error, okay, we can choose a larger alpha. Okay, ideally we don't want any type of error, but you know, we kind of gauge whether type 1 error is good or bad, okay? And you might say, well, if we don't want type 1 error, why don't we just choose to use a small alpha, okay? Well, if we choose to reduce type 1 error by using a small alpha, we increase our risk of type 2 error, okay? So, decreasing alpha will increase the risk of type 2 error, okay? And we assign beta, it looks like a B, it's the second letter of the Greek alphabet. Beta is associated with the probability of type 2 error. Okay, so alpha, the first letter of the alphabet, is type 1 error. Beta, the second letter of the Greek alphabet, is type 2 error. And that's actually where alphabet comes from, alpha, beta. Okay, so decreasing alpha will increase the risk of type 2 error. Beta is the probability of a type 2 error. Okay. So I should also note something, that we give the quantity 1 minus beta is equal to something called power, okay? And power, so whenever you do 1 minus a probability, you're getting the probability of what?
Of the other, the opposite half.
Yeah, of the opposite, right? The complement, okay? So if beta is the probability of a type 2 error, power would be the probability of the complement of a type 2 error. So what would the complement of a type 2 error be? Yeah. Okay, type 2 not happening, right. So what was a type 2 error? Type 2 error meant not rejecting the null when the null was actually wrong. Exactly, okay? So for that not to happen, I'm going to use double negatives here. It'll be not rejecting the null when the null is false, right? So that would actually mean we are rejecting, right? So power is, yeah, 1 minus, it's beta. Yeah, 1 minus beta is equal to power. So power is the probability of correctly rejecting the null hypothesis when the null hypothesis is false. Okay? And this is a good thing, okay? This is a good thing. Power Lots of power is a good thing. Okay. This is the probability of correctly rejecting the null when the null is false. That would be power. Okay. So again, inherently, type 1 error and type 2 error are kind of linked together, because in type 1 error means we've rejected incorrectly, and type 2 error means we didn't reject incorrectly. So if we choose to reject more often, then we won't be not rejecting as often. And if we choose to reject less often, then that means we would be not rejecting more often. Okay, it's just kind of they're inherently linked. Okay, so let me just kind of recap all of this. All right, so if using the same data, okay, so assuming no change in the data, okay, increasing alpha will increase type 1 error, okay, will decrease type 2 error, and will increase power. Okay? So there's a trade-off, right? Increasing type 1 error, but a reduction in type 2 error. On the other hand, I can just flip all of the arrows around. Decreasing alpha will decrease type 1 error, but will increase type 2 error, which will decrease power. Okay? Again, assuming we're using the same data. One way to increase or basically keeping the same alpha but decreasing type 2 error will require collecting more data. That's the only way to kind of increase your power without increasing alpha. Is this okay? All right, so I know this is all very abstract because it's just alphas and betas and type 1 and type 2 error. Let's put this into some context here, okay? All right, so think of a criminal case, okay? Criminal court trial. Criminal case, all right? So in court, there is a defendant, okay? And the reality, okay, there are two things that are possible, okay? Either the defendant is guilty or the defendant is not guilty. Defendant is innocent, really, okay? And in court, we say we assume or we presume blank until proven what, right? Yeah, so we presume innocence until proven guilty, right? So in a hypothesis test, what do we assume is true unless the data tells us to reject it? We assume the null hypothesis. So in court, essentially the null hypothesis is that the defendant is innocent, because this is presumed to be true unless the data or the evidence is presented to convince us that that is not the case, which means the defendant is guilty. Right? And our data is evidence as presented by the prosecution. The burden of proof falls on the prosecution. Okay, data is our evidence. Okay, and then so the jury can make one of two decisions. And what are the two decisions that the jury can make?
Innocent or guilty.
So it's actually not innocent or guilty. It is what? It's guilty and
Not guilty.
guilty and not guilty, right? Guilty versus not guilty. Notice that the jury does not say, we, the jury, find the defendant innocent. The jury always says we find him not guilty, right? This is akin to, if the jury has found the defendant guilty, that means they what? Rejected or did not reject the null?
Didn't reject it.
They rejected the null, right? This is the same as rejecting the null, okay? And if the jury says not guilty, that means they did not reject the null. Okay? And notice, choosing not to reject the null and saying not guilty is not the same as saying the defendant is innocent. Right? It just means there was not enough proof to bring a conviction. Okay? So, in truth, the defendant could actually be guilty, but there wasn't enough evidence to prove his or her guilt. Okay? So, we can all probably think of high-profile cases where we think, things like that have happened, right? Okay, so if the jury says guilty and they reject the null hypothesis, this is what we want, right? This is a good thing if the defendant is guilty, right? Okay. If the jury rejects the null, if the jury concludes that the defendant is guilty, that's a good thing if the defendant is guilty. This is a bad thing if the defendant is innocent. Okay. Agreed? Okay. And if the jury chooses not guilty, this is a good thing if the defendant is innocent, and this is a bad thing if the defendant is guilty. This is also possible, right? Okay. So we say the justice system is working if the defendant is guilty and the jury finds him or her guilty. And the justice system is working if the defendant is innocent and the jury finds him or her not guilty. Okay? And we say that, there were failures of the justice system if the defendant was actually guilty but the jury found him or her not guilty. And we say it's a bad thing if the defendant is innocent and if the jury convicts the defendant. Okay. All right. So, which of these is a type 1 error and which is a type 2 error? Yeah, Mason.
So, if it, for the not guilty,
Uh-huh.
if this says, wait, hold on, man, that's right.
Okay. So, type 1 error is rejecting the null when the null is true. Type 2 is not rejecting when the null is false. So which one is type 1 and which error is a type 2? Yeah.
Well, if you say he's guilty when he's not, that's type 1.
Yes. So finding the rejecting the null or finding that the defendant is guilty when in fact he is innocent, this is a type 1 error. Okay? Finding the person guilty if the defendant is guilty, this is correct decision. Okay? Over here, this is the correct decision, the first one. And this down here is a type 2 error. They did not reject the null when the null is false. Just want to let that sink in, make sure that makes sense to you all. Okay, is this okay? All right. Now, maybe not everyone agrees, but having grown up in America or adopting American values, which error is worse, the type 1 error or the type 2 error? Yeah, type 1, right? So ideally, the justice system doesn't make these mistakes, right? But some mistakes are going to be made because we don't have all the data or all the evidence possible, okay? And so you can either choose to let some guilty people go free, or you can choose to imprison some innocent people, okay? Or possibly execute, depending on the severity of the punishment. Okay, so when the founders of our country decided to set up the justice system, they chose to err on the side of choosing to let guilty people go free than to imprison innocent people. So they made the choice that a type 1 error is worse, okay? Does that make sense to you guys? Okay, so they said it's worse to send an innocent person to jail. So type 1 error is worse than to let a guilty person go free. We don't want either of those to happen, but if we had to choose between making a mistake, right? Do we want to let the possibility of a guilty person go free, or imprison an innocent person? Huh? What do you? Yeah, that's how our justice system is set up. Okay.
So you mean in this case, type 1 error is worse?
Yes, in this situation. Okay. So in this situation, a type 1 error is worse. Okay. So going back a page in your notes, do we want to pick a large alpha or a small alpha? Okay. So if type 1 error is worse than type 2 error, right? We want a small alpha, right? Because we have a choice of alpha, okay? And so decreasing alpha will increase type 2 error, okay? Decreasing alpha will reduce type 1 error, but will increase type 2 error. But that's what we want in this situation, where type 1 error is worse. Okay? So we want a small alpha. And they say this in court, okay? They don't say use a small alpha, but what do they tell the jury?
That this is the evidence is
The benefit of the doubt.
Yeah,
It's beyond a reasonable doubt, right? They tell the jury, don't come to the conclusion of guilty unless you are sure beyond a reasonable doubt, right? They don't want you to just say, I feel like he's guilty, so I'm going to choose guilty, okay? They want it to be like you are almost absolutely convinced that this person is guilty, and that's why you're choosing guilty. If there's a reasonable doubt still in your head, by law, you have to say not guilty. Yes? Yeah, that is the premise, right? Yeah. So, and we can think of a lot of high-profile cases where, maybe watching on TV, you're like, oh my gosh, I'm sure that this person is guilty, but then the jury comes to the conclusion not guilty, and you're always wondering, well, how was that possible? It just means the jury had at least a reasonable doubt. Okay, so Yeah, 12 Angry Men. Excellent classic movie. They did they did it twice. They made two versions of the movie, and they're both very good. So, okay, so I always say beyond a reasonable doubt. Okay. All right. Let me give you another scenario here. Okay. Think of a smoke detector. Okay. Now, what is the job of a smoke detector?
Alert you if there's a fire.
Okay. The purpose you buy a smoke detector is to alert you if there's a fire, right? Should sound alarm if there is a fire. Okay. And then the secondary job inherent to smoke detecting that we don't think about is what?
Let you know that there's no fire if it's not.
Yeah, it should stay silent when there's no fire. Okay, so the default mode, okay, default state is silent or alarm. Silent, right? It's only if there's enough evidence to convince the smoke detector that there is a fire that it sounds the alarm. Okay, so that means it is assuming what? That there is a fire or there is no fire. Yeah, so it assumes the null hypothesis is that there's no fire, and the alternative is that there is a fire. Okay, and rejecting the null is essentially sounding the alarm. Okay, and not rejecting the null means remaining quiet. Okay, rejecting the null is good if there is a fire. Null hypothesis is false. And this is bad if there is no fire. Okay, not rejecting the null, remaining quiet, this is good if there is no fire. And this is bad if there is a fire. Okay, which of these is type 1 error and which of these is type 2 error? Yeah, the question is, so which scenario is a type 1 error and which scenario is a type 2 error? Yeah, Gina.
A type 1 would be saying that would be denying the HL, saying that there is a fire when there isn't.
Yeah, okay, so that would be sounding the alarm when there is no fire. That would be a type 1 error. Okay, and then the type 2 error would be remaining silent when there is a fire. Okay, the other scenarios, sounding the alarm when there is a fire, that's correct operation. and staying quiet when there is no fire, this is also correct operation. There's only one P in operation. Okay, so which error is worse? Yeah, I would say the type 2 error is worse, right? Type 1 error is a false alarm. That's just annoying, but it's not a big deal, okay? Type 2 error is potentially deadly, right? There's actually a fire going on, but the people in the building aren't aware of it, okay? So type 2 error is worse. Okay, so do we want to use a large alpha or small alpha? Yeah, so we use a large alpha. Okay, so that means we want our smoke detectors to be sensitive to detecting smoke. Okay, and so it is almost, we never want false alarms. Okay, we would prefer not to have false alarms, but we would rather have a false alarm than a smoke detector that doesn't work. Okay, and so that's why sometimes it's almost comforting if you have a smoke detector and you burn some toast in the kitchen and it sets off the alarm. You know that your smoke detector works. Okay, even if it's not that big of a deal. Okay, it's a little bit annoying that you have to reset the alarm, but it gives you assurance knowing that, hey, this thing actually works.
So with all of these, like, not rejecting and things like that, it sounds like a lot of double negatives, and I feel like it's confusing. Why, instead of not rejecting the null, why can't we say accepting the null?
Yeah, because not rejecting the null does not prove that the null is true. Okay? So think of any court case, okay, where the jury said we find, that when they acquit the defendant, okay, they don't say we, the jury, find the defendant innocent. They always say not guilty, okay?
So we accept not guilty.
Oh, we're saying not guilty, okay? We're not saying innocent, okay? And there is a difference. There is a difference between not guilty and innocent, okay? And so we have to be careful not to say that the null is true, okay? Because in statistics, all right, so in these situations, it's not that the terminology is not too big of a deal. But say in statistics, and you don't have to write this down, your null hypothesis might be something like mu is 70 or something like that, okay? This means that the mean of the population is 70. This is what this null hypothesis says, okay? The mean of the population is 70, okay? Right? However, the only way that the mean of the population actually is 70 is if the only way for us to know this is if we measure every single person in the population, okay? We measure every single thing, and then we calculate the average of every single person, okay? Do you think that average is going to be exactly 70? Probably not, right? Okay, it's probably not going to be 70. It might be very, very, very close to 70, but it's probably not going to be exactly 70. But notice that's what the null hypothesis is saying. It's saying that the mean is 70, okay? And probably the case is that it's ever so slightly off, but maybe from a practical standpoint that doesn't matter, okay? So you're either going to come to the conclusion that I do have enough evidence to say that the mean is not 70, or I don't have enough evidence to say that it's not 70. Okay, and I know that there's double negatives in there.
Yeah, are there no other words?
Yeah, you can't, because you can't say I have evidence that it proves that it's 70. That's not the case.
Right, but isn't there something in between proving and not rejecting that works?
I can't think of anything, okay? Okay? I'm not going to... Yeah, the jury might be tempted to say we find the defendant innocent, but that's not correct, okay? So you have to say not guilty, and it's just, that's how we do it, okay? And it's only, in English, when you say not something, then it cancels out and things like that. In other languages, it's either, think there's some nuance in English, and that's just how it goes. And I'm sorry that it is a little confusing, but that's the nature of that, okay? Let's take a short break, okay? And then we'll come back and I'll cover the sampling methods, and we'll also begin our review.